Very good morning, students. Welcome to IIT NEET Foundation or Focus C program by Krishnaveni Talent Schools and the Mastermind Schools. Once again, I welcome all the class 7 students of various branches for today's session. As you all can see on the screen, and you are well aware, my subject is physics. We are in class 7th. Our ongoing chapter, electricity, which is the last chapter of the chapter number 8, last chapter of the material. And today again we are entering into the session number 3. So far we completed 2 sessions on electricity, where we discussed about the prehistory of electricity to till the date, how the electricity is developed and how the electricity becomes an important in our day-to-day life. Because when you go to your grandparents or great-grandparents, they don't have any electricity, but still they survived. But today, we cannot imagine our life without electricity. Correct? If electricity goes, world will stop. Like that we feel. We are addicted towards electricity. Such a wonderful form of energy electricity is, which makes our lives bright and our futures to grow. So before going for the today's topics, we continue where we left in the last class. But before that, let us rewind. Let us rewind what we learned in the last 2 sessions, right? Okay. So this is our, as per the material, electricity. What we learned in the last classes, we learned about what is the electricity, which is observed a long back by a Greek philosopher, Thales, right? And he identified that there are 2 types of charges. One is positive charge, other one is negative charge. We have seen what are the properties of charges also. And this charging can be done. Means you can transfer the charges one body to another body by friction, by rubbing, by conduction, by touching, by induction, even without direct touching also, by influence. Without direct contact also, we can transfer a charge from one body to another body. By this way, we can transfer the charges either by friction or by conduction or by induction. We can transfer a charge from one body to another body. Then how to detect the charge? Suppose you have one body. I have pen with me, right? Whether the pen is having charge or not. If charge is there, what kind of charge? How to test? We have seen about the electroscope. Gold leaf electroscope, which we discussed in the last class, where we learn about how to detect presence of charge and kind of charge. If charge is there, what kind it is? Okay. We discussed about that in the last class. Then, even in atmosphere also, you can see that electricity, like in thunders, we can find electricity, which is called atmospheric electricity, which is proved by the Benjamin Franklin, right? So Benjamin Franklin, who found that there is electricity in the atmosphere also, because of, atmosphere contains so many gases. So whenever thunder comes, electricity will come. Whenever you are flying a kite, from that also you can show that electricity is present in the atmosphere also by famous scientist Benjamin Franklin. Then we have seen about few more definitions like electric current. Current is nothing but rate of flow of charge. How charge is flowing, how fast charge is flowing is called as current. That is I is equal to Q by T, which is measured in ampere and measured by a device called ammeter. Whenever TV mechanic or any mechanic come to your house, check. You can find one meter which is named as A, letter A, ammeter, which is used to measure the how much current is passing, right? So electric current is measured by an ammeter. So direction of electric current. So electric current direction is always from positive to negative. Positive to negative only, because as per the convention, everything is flows from high to low only. Water from high level to low level, heat from high temperature to low temperature, air from high pressure to low pressure. Similarly, electric current also from higher potential to lower potential. That higher potential is called positive. Okay. And electromotive force means, suppose when you are using any electrical device like cell, battery, generator, transformer, or any domestic other one, inverters, all these are having some capacity. How much energy, how much current the source is supplying is called as electromotive force, right? There. Now today we'll come to what are the various applications. What is applications? Means uses. Application is not the application applied for the something, right? Applications are nothing but in what way electricity is useful for us. What are the various applications of electricity in our day-to-day life? Very important one, because physics is the subject of application only. It's not a other part. Every chapter of physics is applicable in our day-to-day life. We can use. We are using. There is no other alternative. Either it is a magnetism or electricity, sound, light. All these are our day-to-day applications only. Electricity is the most convenient form of energy that can be converted into various other forms. We can convert the electricity into heat, electricity into light, electricity into picture, electricity into so many other ways, sound, right? It has various applications and has become part of human life. Different applications of electricity are possible due to different effects that electricity can be produced. Electricity can be produced the magnetism, and effect is called magnetic effects of electricity. The first effect, magnetism effect. Okay. Similarly, if electricity brings out chemical changes in a substance, the effect is called as chemical effect of electricity, right? Likewise, if electricity brings out heat in the substance, the effect is called heating effects of electricity. Of course, light also there, lighting effects. Fourth one. So whenever you are passes electricity through various chemicals or various magnetic materials or various heating substances, it can produce the different kinds of effects. All metals are good conductors of electricity because of they have free electrons in them for a conductor. It was also observed that liquids also conduct electricity. For example, lemon juice is a good conductor of electricity, while some liquids such as distilled water are poor conductors of electricity. When salt is dissolved in distilled water, it becomes a good conductor. We can see the electrolysis process. You are learning from your childhood. Electrolysis or electrolysis, right? That we'll see next. Right. Then, hence the tap water, water from the hand pump, well, and pond are the good conductors because they contain the salt. Conductors of electricity, as all these have small quantity of mineral salts naturally present in them. Most liquids that conduct electricity are solutions of acid, bases, and salts. Right? Now, as I told, there is a different effects are there. Just first we'll see the chemical effect of electricity. What? Chemical effect. So what is the chemical effect? Whenever you are passing electric current through a liquid chemical, the liquid chemical, then some effect you can see, some chemical changes you can see. So that liquid chemical is called electrolyte. Either it may be salt water or any other chemical. So the first effect, the passage of electricity through conducting solution causes chemical reaction. As a result, a bubbles of gas may be formed in the electrodes. Deposit of metals may be seen on the electrodes. Changes in the color of solution may occur. The reaction will depend on the what solution and electrodes you are using. These are the some chemical effects of the electric current. Hence, electricity flowing through a electrolyte, electric conductor in liquid is called electrolyte, liquid form. Right? A chemical effect of electricity. The most taken into the conducting can cause chemical reactions in the electrolyte. This is known as chemical effect of electricity. The most commonly occurring chemical reaction in a reaction is electrolyte. A chemical decomposition the process of splitting. For example, see, calcium carbonate is there. When you are passing electricity from this, it deposits calcium oxide and carbon dioxide, either heating or electricity. That is called decomposition. So, passing the electricity can be decompose the chemical. Right? The process of producing chemical decomposition of a compound by passing electricity through compound is known as electrolysis. Electrolysis is popular, and the solution through which electricity passes is called electrolyte. The solution is called electrolyte and the process is called electrolysis. We can see now, right? So connected to positive terminal and greenish blue spot was observed. Hence, a potato can be used to identify the positive terminal of the battery. So you can produce even electricity from potato also. You can see in the small science phase, right? Now, how this effect takes place, we'll see through one example, that is electrolysis, one application, and many more are there. So electrolysis of water comes under chemical effect of electricity. When you pass current through water, ordinary water is the insulator. It does not have electricity. So what we'll do, we'll add some pinch of salt. When salt is dissolved in the water and electricity passes, what happened here? So water is split into hydrogen gas and oxygen. Right? 2H2O2 divided into both gases. Gases will come and collect in the glass tubes. That is called decomposition. That is called chemical effect. Whenever electric current passes through the salt solution, the water deposit separates into hydrogen and oxygen. Such process is called electrolysis of water. Right? Very, very, very important. Commonly used chemical effect of electric current. Now, when you come for the applications where this chemical effect is used, first one is electroplating. For example, if you see utensils in our house, like plate, bowl, glasses, stainless steel we call. What is the stainless steel? Stainless steel is nothing but coating chromium on steel. Right? Steel plus chromium. So whenever chromium is coated on the steel, it becomes stainless steel. For long, sir, what happens if you steel like that only? It will rust. Suppose you use only steel utensils. So because of oxidation in air, the steel will rust. So to protect from the steel, what we are doing? We are coating with the chromium. Then it becomes stainless steel. It won't be rusted easily. It stands for long time. That is called electroplating. Coating one metal over the other. What? Coating one metal over the other. Why you are coating? To protect from the oxidation. Right? Any metals are there. What will do? Paint. Gate is there. Metal gate. What will do? We'll paint gate. Why you are painting? To protect from the rusting. To protect from rusting. That method is called electroplating. Electroplating. Okay. Then the second is gold covering. You might have heard 1 gram gold. What is 1 gram gold? They are coating one metal over the other. Either maybe silver can be coated with a gold, or any other chemicals can be coated to make it as a 1 gram gold. Or silver and gold also can be coated one over the other. That coating is called gold coat covering. The gold covering is also done by electrolysis, which is the effect of electricity. Then metallurgical application. Metallurgical means in industries, metals can be obtained. How you are getting the iron, how you are getting the steel, how you are getting the copper, how you are getting the aluminium. They cannot get directly from the crust. They need to extract by industry. So we can get iron from the ores of iron by the method called electrolysis. Of course, gold and silver, they obtain in the nature state only. Directly they need only refining or cleaning. But whereas other metals, they need to go for the metallurgical process. That is, they need to be electrolysis. So in our industries, metals can be obtained from their ores by extraction. That method is called metallurgy. Metallurgical process, you can get the metals. That is also one of the important application of the chemical effect of the current, electric current, right? And next, we have safety devices. Very important. You know all. Fuse. Hope you all know fuse, right? In every home, maybe one for one room or common for all, we have fuses. Once upon a day, there are big fuses are there, but nowadays we are getting a simple one. The fuse is the one which is safety device, which can protect our electrical appliance from high voltage. Sometimes voltage will come high. Maybe your fridge or TV may blast. To protect from that, we'll use the fuse, right? So fuse is called the safety device. A fuse is a small piece of wire. It is made up of special alloy. Alloy is nothing but mixture. Gets heated quickly and melts. If the current in the circuit is high, the fuse wire gets hot and melts. This leaves the gap in the circuit. Automatically, the circuit is broken and flow of electricity stopped. This protects the application from getting burned due to passage of large current. So to avoid from the high voltage current damage of electrical appliances, fuses are used. A wire is made up of a material with a low melting point. Next, miniature circuit breaker. You know MCB. Nowadays we are running MCB switches. MCB, miniature circuit breakers. Whenever current high will come, automatically will stop the current. Right? These are the switches that automatically turn off when the current circuit exceeds the safe limit. Automatically it will disconnect the circuit. Very interesting. It has a switch off that goes automatically if there is a overheating. This breaks the circuit. If we turn on the circuit once again complete. This advantage of MCB over fuse is MCB can be reset to the restore the normal position. Fuse again you have to replace. Once it is burned you have to replace. But MCB no need. Again you can on. Automatically on. So these two which we can see in our houses as a safety devices where we can protect our electrical appliances like fridge, TV, radio, computers, mobile phones. All these can be protected from these safety devices, right? So before going for the next part, let me show you one video on this. Okay. You can check video on what is exactly effect of electricity. Okay.
Electric circuit. The closed conducting path in which the electric current flows is called an electric circuit. An electric circuit constitutes of a source of electric current, cells, etc.
Good to see Gidalur branch students are writing the notes. Very good.
Conducting wire, an electrical appliance, bulbs, etc. A switch or key. When the switch is closed, the circuit is said to be closed circuit. In this condition, current flows and appliance works. Example, the bulb glows. However, the circuit is said to be open circuit when switch is open and there is no flow of current. Source of electric current. A device that produces an electric current is called a source of electric current. Example, cells, batteries, etc. Battery. When two or more cells are used to draw an electric current, the combination of cells is called battery. In battery, positive terminal of one cell is connected to the negative terminal of the next cell. Many devices such as torches, transistors, toys, TV remote controls use batteries. Bulb. It produces light and is represented by coiled wire inside the circle as shown. Connecting wire. The connecting wire is represented by a straight line. It is usually made of copper and provided with insulation. Plug key. A plug key is an electric switch. It is shown in both on and off positions in figure. Cell. A thin long line represent the plus terminal and thick short line the negative terminal as shown. Battery. A combination of two or more cells is called battery. Its symbol is also a combination of cells symbol as shown. Fuse. It is safety device in electric circuits. The components such as cells, bulbs, wires, etc. are called elements of an electrical circuit. The various components of the circuit are represented by standard circuit symbols. It is much easier to draw a circuit diagram using symbols. Therefore, we generally represent an electric circuit by its circuit diagram as shown. Symbols of some common components are shown. Heating effect of current. When an electric bulb glows,
we discuss about chemical effect. Now this is also heating effect. Means when you pass current, it produces heat. You can see in bulb. When you pass current in the bulb for some time and touch, you can feel that bulb become hot. Because that is a heating effect of electricity and gives a light also, which is called lighting effect.
continuously for a long time, it becomes very hot as some part of the electrical energy is converted into heat energy. This is known as heating effect of current. The heating element in many electrical appliances like electric rod, electric oven, electric toaster, etc. is made of nichrome alloy. Take a 10 cm long piece of nichrome wire, tie it between the nails. Now touch the wire and switch on the current in the circuit by moving the switch to on position. Touch the wire again. Do not hold the wire for a long time and switch off the current. Touch the wire again. After a few minutes, we will observe that the wire becomes hot when an electric current passes through it. This is the heating effect of the electric current. Safety devices. Mini circuit breaker used to protect circuit.
It's called MCB, mini circuit breaker, which is the safety device. Just now we discussed. Mini circuit breakers. You can see in your houses, right?
From strong current often leads to overheating of wires, which can result in the breakout of fire. Fuse also used for protection of circuit, which consists of a thin wire of low melting point. In 1820, the Danish physicist Hans Christian Ørsted discovered that flowing current in a conductor generates a magnetic field.
Next to magnetic.
Ørsted demonstrated this by connecting the two ends of wire to a cell through a switch. Then he placed magnetic compass near the wire. Now when he allowed the current to pass through the wire by closing the switch, he observed deflection in magnetic needle. He also noticed that it requires its original position when the flow of current is stopped. Take a discarded matchbox and wind an electric wire a few times around the cardboard. Place a small compass needle inside it and connect the free ends of the wire to an electric cell through a switch. Note the direction of the compass needle. Bring a bar magnet near the compass needle. We will observe that the needle gets deflected. At the same time, move the switch to the on position. We will again observe that the needle gets deflected again. Now move the switch back to the off position. We will observe that the needle comes back to its original position. So, we conclude that when electric current passes through a wire, it behaves like a magnet. Take the tray from inside a discarded matchbox. Wrap an electric wire a few times around the tray.
Just simple experiments to know the magnetic effect of electric current.
Place a small compass needle inside it. Now, connect one free end of the wire to the terminal of a battery. Leave the other end free. Take another piece of wire and connect it to the other terminal of the battery. Insert free end of wires into half cut of potato and observe. You will observe that a compass needle gets deflected and also find that it was always the wire connected to the positive terminal which has greenish blue spot around it. They felt that the discovery was very useful because it could be used for identifying the positive terminal of a cell or a battery concealed in a box.
Dear Shopify store owners, with the right shipping app, the order fulfillment process can be streamlined.
Electromagnets. Current-carrying wire or a coil of wire behaves like a magnet. If a permanent magnet is brought near the coil, one end of the coil gets attracted and the other end gets repelled. This shows the opposite polarity of the coil. If a piece of soft iron is kept inside this current-carrying coil, the iron piece gets magnetized temporarily. Such magnets are called electromagnets.
Electric bell.
Bell, you can see how bell will work.
Electric bell is one of the most commonly used applications of electromagnets. It works on the magnetic effect of current. It produces a repetitive buzzing or ringing sound when an electric current is passed through it. Electric bells have been widely used in telephones, fire, and burglar alarms. at railroad crossings, as doorbells, school bells, and alarms in industrial plants, but they're now being replaced with electronic sounders. An electronic bell consists of an electromagnet, springy iron strip, a hammer, a gong, and a switch. An electric bell works on the principle of electromagnetism. It is a simple device which has a U-shaped solenoid, one end of which is connected to a spring of the...
Okay, anyway, so it's a wonderful explanation about the total, our chapter. All the effects of electricity seen in the single video, not only magnetic effects, not only safety devices, it also explains about the heating effects, lighting effects, magnetic effects, which we are going to learn in the next classes, right? In details. So this is the one part of the chapter here. When you move to the next part, after completing all these things, we can start again. The one more part is there, which we are going to complete in the when we meet in the next class, that is on Friday. We can complete about the some more important information about the electricity, some definitions, some units, some formulas about the different type of cells and batteries we'll use in our day-to-day life, how they are useful. Everything you can discuss in the next 2 or 3 classes to complete our entire syllabus, right? See, so many things are there to learn. How electricity is helpful for in our day-to-day life. That is called applications, and all you can discuss in the coming classes, right? So hope you are understood the today's topics completely about electricity and effects of electricity, especially applications of electricity, how they are applicable in our day-to-day life. Either it may be gold covering, or it may be electroplating, or it may be electrolysis, right? In maybe metallurgy, to extract the metals from ores, we'll use the chemical effects, right? So that's all for today, students. Have a wonderful day. Thank you, all of you. Thank you.